Okay, we're going to continue our lesson on adding and subtracting rational expressions. We've mentioned this before, just a few reminders. Just like when we're adding fractions, which is basically what a rational expression is, when we're adding or subtracting with those, we must make sure the denominators are the same. And if they're not the same, we need to look to find a way to make them the same. So once we recognize that our denominators are not the same in a problem of addition or subtraction, we're going to want to go ahead and start factoring both of the denominators. And we'll use the factors of the denominators in order to determine the least common denominator. Now, the least common denominator will include every factor that makes up the denominators. Okay, we're going to get a piece of every factor that's there. Now, some of them might be there multiple times, but we will include every one of them in there, and that'll help us identify what the least common denominator will be. Once we do that, we're going to multiply whatever factor we need to get the denominators to be the same so that they are that common denominator. And once we get the denominators the same, we will add or subtract the numerators. And of course, we'd always finish by simplifying any answer, doing any simplification that we can. Let's look at a couple of examples here. In example 1, we're going to add, and you look at this problem, 4x plus 1 over x minus 4 plus 2x plus 7 over x minus 4. We can see that the denominators are both the same. So we already know what our least common denominator is. It's x minus 4. We don't have to worry about identifying it or going through some lengthy process to find it because they're already the same. It's the common denominator already listed. So at that point, all we must do is add the numerators. To add the numerators of course are 4x plus 1 and 2x plus 7. So we'll say 4x plus 2x, that would be 6x. And then we will take 1 and plus 7. So 1 plus 7 of course is 8. So we have 6x plus 8 over x minus 4. Now we might want to clean that up a little bit. You may notice that we have a GCF that goes into 6x plus 8. That would be 2. So we could take a 2 out, and that would leave us with 3x plus 4 over x minus 4. If we have any other simplification, meaning any other factors that cancel out in this case, we would go ahead and do so this time. However, in this particular problem, nothing cancels out, so there you go. 2 times 3x plus 4 over x minus 4 is our sum, our final answer. Example 2 is a similar situation. We have a least common denominator already there. As we can see, the two denominators are both the same. So we can proceed with this problem knowing that the least common denominator is going to be 2x minus 5. So we'll just use that information, and at that point we're just going to, in this case, subtract the numerators, because this is a subtraction problem. So we're going to take our answer, we'll have a 2x minus 5 on the bottom, and we're going to take 3x minus 5x, which is negative 2x, and we've got negative 1 minus negative 2, and again minus negative 2. You might want to keep in mind that when we subtract a negative, that's going to change to a plus. So that's negative 1, actually plus 2 is what it ends up being. So that's negative 2x plus 1 over 2x minus 5. There's nothing to factor here, nothing to cancel out. You might initially say, well, the 2x's cancel out, but remember, we can only cancel out entire factors when we go to simplify a rational expression. We can't cancel out parts of a sum or a difference. So we can't just cancel out 2x's like that. So our final answer is 2x plus 1 over 2x minus 5. So we've had a look here at a couple of easier problems because the denominators were both the same in these problems, so it worked out for us to go ahead and just combine the numerators without having to make any modifications. Now let's look at a few more examples. In this example, example 3, we can see that our denominators are not the same. One is an x and one is an x plus 5. So this could present an issue for us in doing this. So we're going to have to make some adjustments here and fix this up. So first off, we factor out anything in the denominators that we can. In this particular case though, x is not going to factor out anymore, and x plus 5 is not going to factor out anymore. So we're pretty much stuck with what we have. So the factors are x and x plus 5, and remember we said that the least common denominator will include all factors. Okay, make sure we do that. So we want to include every factor that's there in the least common denominator. So that would make it x and x plus 5. Those are what we would call our prime factors of the denominators. So our least common denominator will include both of those. And we're going to go ahead and now set up our problem so that we have x and x plus 5 in the denominator of both of these fractions. Now, we started off the problem with an 8 in the numerator of the first fraction. However, we started with just an x, so we needed to get to x times x plus 5. So in order to do that, we're going to need to multiply in an x plus 5 in the numerator as well, so that we have, so that we're able to put that in the denominator. Originally we had a 3x, we had a 3x in the numerator of the second fraction, and the second fraction had an x plus 5 as its denominator. Well, it's missing one piece here, and that piece is the x in the denominator. So we're going to need to multiply an x in here so that we get that x in the denominator as well. This is our way of making sure that things stay balanced. If we put something into the denominator of a fraction, we have to put it into the numerator as well. So once we've got this, we're going to now multiply out everything that's there and get our actual problem. We have x times x plus 5, again, in the denominator of both fractions. And our numerator for the first fraction would be 8x plus 40. Our second numerator would be 3x squared. Now we'll pay attention to the negative sign here, and basically we're just going to put everything in the numerators together. 8x plus 40 minus 3x squared all over x times x plus 5. Excuse me. In doing this now, we'll just rearrange, because we know that we shouldn't put the x squared as the last term, so we'll write it in the proper order. We have negative 3x squared, positive 8x, and positive 40, all over x times x plus 5. This is our final answer. And what we've done is we've gotten the denominators to be the same by multiplying values in to the numerator and denominator so that they both turn out to be the same. And once we got them to be the same, it was really just a matter of combining like terms or putting the terms together from the numerators. So let's continue by taking a look at another example here. 3x squared minus 1 over x squared minus 3x minus 18 minus x plus 2 over x minus 6. Now you can see in this particular case that we do not have common denominators. I think it's pretty obvious. The numbers on the bottom are not the same. So what we need to do is start off by factoring our denominators. Well, if we look at the first denominator, we've got x squared minus 3x minus 18. We're looking for factors of negative 18 that will subtract to make negative 3. And since we don't have a lead coefficient over here, we can just use our shortcut method and identify those factors would be negative 6 and positive 3. So we have x minus 6, x plus 3 there. And when we look at the second fraction, we have an x plus 2 there on top. I guess I should put that in parentheses. We have an x minus 6 here. Well, remember our least common denominator is going to include all of the factors. Well, x minus 6 doesn't factor down anymore, so our least common denominator is going to include all of the factors. That would be x minus 6, which is actually there twice, but we'll just put it once, and x plus 3. So that becomes our least common denominator. We want both fractions to have that on the bottom. So we can look at this first fraction and see that it's already got that there. So we're good in that particular case. We don't need to worry about putting anything else into that fraction. But we do in the second fraction need to put one thing in here. So we will multiply one value in, and it's missing in x plus 3. So we will multiply that to the denominator of the second fraction. And if we do it to the denominator, we must multiply it to the numerator. So we'll multiply x plus 3 there. And that is how we set up to get our least common denominator. So we have two fractions now that have the same denominator. So what we're going to do now is combine these. But before we combine, we have to do something with this second fraction. We're going to have to do some multiplication here to clear this up. So I'm going to go ahead and start multiplying this part. That would be x squared plus 3x plus 2x plus 6. And we can obviously combine those two, which we'll do here in a second. When we write our second fraction out, that would be x squared plus 5x plus 6. And of course, again, that's over x minus 6, x plus 3. Over here, we've got 3x squared, 3x squared minus 1 over x minus 6, x plus 3. So we're now going to put our numerators together by subtracting. Okay, so let me extend the screen here a little bit, and we're going to subtract this. Remember, when we subtract, we basically just take that second polynomial and we'll change all of the signs in that second polynomial. So what we have when we start putting things together is 3x squared minus 1 minus x squared minus 5x minus 6. And again, that's going to all be over our common denominator of x minus 6, x plus 3. Excuse me. So we'll just collect our like terms at this point now that we've changed all the signs in the second terms, or the second polynomial. So we have 3x squared minus x squared, that makes 2x squared. We have a negative 5x here. And we have minus 1 and minus 6 make minus 7. And that is all over x minus 6, x plus 3. And this is our simplified answer. It doesn't simplify anymore, so that'll be our final answer in this case. So again, recapping, we factored out our denominators, or the denominator that we could factor out. We factored our first one into x minus 6, x plus 3. And then we took a piece of every factor that was there to identify our least common denominator. And we realized that to get that least common denominator in the second fraction, we had to multiply x plus 3 to the top and the bottom, or to the numerator and denominator. And that gave us common denominators. So once we did that, we used the FOIL method and collected like terms to arrive at our final answer of 2x squared minus 5x minus 7. Okay, let's look at one more example here. 3 over x plus 2 plus 5x over x squared plus 2x minus 3. Again, we see that the denominators are not the same, so we need to find a common denominator. Our first step is to factor out our denominators wherever possible. Well, x plus 2 does not factor in the first one, so we'll have to keep it. In the second one, we can see x squared plus 2x minus 3 does factor. The factors of negative 3 that will make 2 when we subtract will be positive 3 and negative 1. Positive 3 and negative 1 would make positive 2. So we have x plus 3 and x minus 1. We also have x plus 2 as part of our factor in the first one. So our least common denominator, and remember, the least common denominator includes all factors. Our least common denominator in this case will be x plus 3, x minus 1, and x plus 2. So we have to deal with this, and we'll have to get that on the bottom of both of our fractions. So let's go ahead and start to do that. We have the first one, we already have x plus 2, and we have 3 on top. The second one, we already have x plus 3 and x minus 1 there. That's the factored out version that we had from what we had the original problem. So the first problem, or the first factor, first fraction, we'll need an x plus 3 and an x minus 1 multiplied in there. So we're going to just do that. We'll need an x plus 3 on the bottom and an x minus 1. If we multiply that to the bottom, though, we have to also do that to the top. And that's going to be a few things to multiply together there, but we can handle it. On the second fraction, we're missing, we have an x plus 3, we have an x minus 1. We don't have an x plus 2, so we need to get that in there. So we'll multiply that to the top of that one as well. So now we can identify the pieces that had to be put together to get those common denominators, and then we're just going to start multiplying. This first one, we'll just start off distributing 3x plus 9, and we'll come in and bring the second part in a moment. That's over x plus 2, x plus 3, and x minus 1. In the second one, we're going to distribute here as well. 5x times x is going to be 5x squared plus 10x. Don't forget the x. And that's over x plus 3, x minus 1, and x plus 2. Now, we still have some multiplication to be done on the top of the first problem, or the first fraction, so let's go ahead and multiply that out. Let's see if we can scoot all this up. We've got 3x times x is going to be 3x squared. 3x times minus 1 would be minus 3x. 9 times x makes plus 9x. And 9 times negative 1 would make minus 9. So we're going to now put all of this together, collect our like terms, and I'll try and rewrite it out here. We have 3x squared plus 6x minus 9. That's just collecting like terms. That's all over x plus 2, x plus 3, and x minus 1. Now we'll go to our second fraction and look at what we have to combine with it. 5x squared plus 10x. My smartboard is lagging a little bit today, but you get it. X plus 3, x minus 1, and x plus 2. So we're just going to add this together. 3x squared plus 5x squared makes 8x squared. 6x plus 10x would make plus 16x. And then we have the minus 9 there, of course. All of that over x plus 2, x plus 3, and x minus 1. And that is our final answer. It's simplified out as much as we can. The top does not factor, so there's nothing we can break down. So we get as a final answer 8x squared plus 16x minus 9 over x plus 2, x plus 3, x minus 1. Again, basically this comes down to our ability to factor out our denominators and decide what our least common denominator should be. By factoring out, we include all of the factors and we multiply into the numerator to get those factors on the bottom and the top. And once we do that, we then combine our like terms and get our final answer. Okay, that's all for today. Hopefully you got a little bit of it, and remember, you must practice this. If you're a little shaky with it right now, the more practice you do, the more problems you work out, the more comfortable you'll get with it. And remember that you have to put in the hard work to learn how to do this. Hope you have a great day, and I will talk to you soon.